Hello, today's video lesson is about a trig problem from Chapter 9 in the Cambridge IB High-Level textbook. It's in the review section at the back in the long questions, and besides the fact that somebody asked me about this, I thought this was worthwhile to make a video, mainly because of the phrasing issues that are here. I just wanted to mention this because whenever IB, on an actual IB exam, says the phrase write down, the implication is that you can just tell by inspecting the problem. You just look at the given information and you should be able to extract whatever information they wanted you to write down. This is a poorly phrased problem because the only way to really find the coordinates of point A are to know the values of K and C. So the better way to phrase this would have been find the values of K and C, and then the second part would have been hence write down the coordinates of A. And just to make sure I was right about that, I looked in the solutions manual for the text, and that's exactly the procedure that they used. So this problem is poorly worded. Nonetheless, the other reason I wanted to talk about this problem is because of the emphasis on graphical analysis. All too often, students in higher level classes get hung up over the symbolic analysis, the analytical stuff. But the fact is that if you can learn how to perceive mathematics graphically as well as analytically, it's going to make you a much better student. And as you can see, IB is accustomed to asking questions that are graphically based, not just analytically based. So here's how I actually get the answers to these questions. I'm going to go pretty quickly because there's a lot of details here. If I'm going too fast, simply pause the video and think about what was said until you get it and then move on. So for starters, here's some information that I know. Based on this equation, there's a K shift to the right and a C shift up. So I wanted to graph original sine wave just so I can see how it's shifted to the right and shifted up to produce the graph that was given in this information. As you can see, my graph crosses the x-axis at 4 pi over 3 and has all of the other features. It crosses the x-axis at 0 and 2 pi as well. So what that does is it enables me to find the value of k. Here's how I do it. I know that from 0 to 4 pi over 3, we get that upper part of the sine curve, and I know that that's symmetrical. Therefore, I can assume that the maximum occurs at 2 pi over 3. That's one way to look at the value for the x-coordinate of A. The other way to look at the value for the x-coordinate of A is A used to be pi over 2 units away from the start. In other words, we start a sine wave, and then pi over 2 units later, we're at its maximum. But I shifted to the right k. So really, this length from the maximum back to the y-axis is k plus the additional pi over 2 that I had. In other words, since my maximum is when x equals 2 pi over 3, I know that k plus pi over 2 should equal 2 pi over 3, and we can solve to find out what the value of k should have been. Simple algebra tells us that k was pi over 6. So now I know that k is pi over 6. That means that the graph of the sine wave was shifted to the right pi over 6 units and then up c. Now I need to find c. Well, that's where I look at other information, and what I notice is there's another 0 given in the problem that when x is 4 pi over 3, the y value equals 0. If I know k, and I know x, and I know y, the only unknown left in the equation is c. So I put in all the values known and solve for the unknown. It's good to know that the sine of pi over 7 pi over 6 is, puts us in the third quadrant, which is going to be a negative value, and pi over 6 is 30, so this is going to be negative 1/2, and c equals 1/2. Now that we know that c equals 1/2, the coordinates of A are 2 pi over 3, comma, 1.5. So that takes care of that. And again, I answered in the reverse order because that's just a logical way to do that based on the given information. Next question was asking to find all of the zeros of the function from negative 4 pi to 0. So what I need to do is to take the original graph and shift it or transfer it periodically back 2 cycles. And in so doing, I can identify, first of all, the easiest zeros to find, which are, we started here at 0, we shift back 2 pi, and we shift back another 2 pi. Those are the easiest 3 zeros in that set, or over that domain. The next ones are simply a matter of taking 4 pi over 3 and then going 2 pi back. So if I could actually subtract 4 pi over 3 minus 2 pi, or I can count over by thirds, 1, 2, 3, 4, 5, 6 pi over 3 back. And so for 4 pi over 3, back 6 pi over 3 puts us to negative 2 pi over 3. Count another 6 pi over 3 back, and we're over here at negative 8 pi over 3. So that's where the other 2 of the 5 zeros come from. The only other thing I want to talk about is pay attention to the details. The negative 4 pi and the 0 are included in the domain, so I can include these two zeros. If these were round brackets or inverted brackets, I would not include the negative 4 pi or the 0 and only have 3 solutions. For the last part, it's asking us to extend the graph out to 9 pi. But then it's also saying, look, there's a horizontal line. There's y equals k, where k is just some number between 0 and negative 1/2, which basically means this is y equals k, and it could be up anywhere in this area from negative 1/2 up to 0. So I don't know exactly where these solutions are because I don't know exactly what k is, but I do know that there are 2 solutions, and they are going to exist between 4 pi over 3 and 2 pi. Now, if I was to extend that graph out, so from 2 pi, that gives me 2 solutions. I go another 2 pi, that's going to give me 2 solutions. And I keep on doing that until I get to 9 pi. I'm going to see that basically 1 pi, in 1 pi there's no solutions, but by the time I get to 2 pi, there's 2 solutions. 3 pi, still 2 solutions. 4 pi, now I've got 4 solutions, and so on and so on. I draw it out, but again, the video is getting a little long, so I just wanted to just tell you that all you have to do is extend this pattern out until you get to 9 pi and count the number of intersections, and it will turn out to be 2 solutions per cycle, 8 solutions altogether, and you can see that if you expanded the graph. The harder question was, they said, all right, look, there's the first intersection that we get, this guy right here, is alpha, some unknown value, but it's basically an x distance from the origin. So that's alpha, and that is the first solution when f of x is equal to k. The next solution is easiest to find anyway, is if we add 2 pi to that, we'll get the first solution on the next cycle. So that should be pretty straightforward. To come up with this guy right here, though, this is the solution in the middle. This one's a little bit trickier to come by because I don't know how far apart they are on the inside. But here is something that I do know, that if I was to go all the way over here to 10 pi over 3, and then I was to go back alpha, that would put me here based on the symmetry. In other words, from this x-intercept, I went alpha, boosh, and I got the intersection. So from the other side, I'm going to go back alpha, boosh, and I get the other solution. So in other words, the first solution is going to be alpha, the second solution is going to be 10 pi over 3 minus a, and then the next solution is going to be 2 pi plus alpha, or a. So I obviously wrote over some of my earlier work there, but I'm sure you guys can figure that out. And again, like I said, pause this if you don't understand where the 10 pi over 3 minus alpha came from. But it's just basically the idea of if I go here and walk alpha, I intersect the curve. So if I go back the other direction and walk backwards alpha, I should get the other spot. And that's how I found it. So hope that's helpful. Have a great day.